Next, we can talk about the 6 main ways that we classify triangles based on angles and sides, where we say that a triangle is acute if all 3 of its angles are acute, that is, all 3 are less than 90 degrees, excuse me. We would also say that a triangle is right, that is, it is a right triangle if one of the angle measures is 90 degrees. You can only possibly have one, and then there's some really special relationships with right triangles that we'll be seeing more of later. And then our last case for angles is we have the obtuse triangle, which is formed by one angle being greater than 90 degrees, but it still has to be less than a straight angle, otherwise you just make a line. On the other hand, if we classify by sides, we can have what is called an isosceles triangle, where 2 sides have the same length. So you can think of that third side as being isolated, hence the name isosceles. We have equilateral triangles, where all 3 sides have the same length. These are also sometimes called equiangular triangles, because in that case, all angles also have to be 60. And then our last one is the scalene triangle, in which no pair of sides, no 2 sides have the same length. So those are our main types of triangles as classified by lengths and angle measures. The other big property that we have when we're talking about triangles is the idea of similar triangles, where we say triangles are similar if they have the same angles but different side lengths. So I'll just say different sides. So for that, we can think of a picture something like this, where for that type of relationship between the 2 triangles, we say that corresponding angles are the ones of the same measure, and corresponding sides are the sides opposite of the corresponding angles. Say the word corresponding too many times and start to just lose all meaning, just keep saying it more and more and more. It's not very helpful. But the big thing that we have here, the big helpful relationship, is that when we're looking at corresponding sides, like we can see on this picture here, they will be proportional. So, for example, we can look at the relationship between the sides opposite D and A. See that they are 4/8, and how that's the same kind of relationship that we get between the sides opposite C and F, 2 and 4. That is, the sides of the smaller triangle are twice that of the larger triangle, or half that of the larger triangle, excuse me. Sorry about that. But that's our big relationship for similar triangles, is that proportionality, that we have consistency between sides if we have the same angles.